Okay, so guys, this is section 1.6, equations and inequalities with absolute value. So let me give you some notes. So let's start with the note that to solve equations with absolute value, use this information. So when you solve equations with absolute value or later inequalities with absolute value, you're always going to solve two equations or two inequalities. So this is what you're going to use. Absolute value of expression, I call it U, equal A. This is equivalent to that U is equal A or U is equal negative A. So absolute value represents the distance on the number line from 0. So when you have negative number, we all know that the absolute value of negative number is positive because we're just counting the distance. Let's say if you have to find the absolute value of -4. So I'm asking you, what is the distance from -4 to 0? So you just count the spaces and we know it's 4. So to solve the equation like this, we're going to break it down into two equations. The first one, you're just removing absolute value, and it looks like your original. The second equation, you replace A with negative A. Okay, and I'm going to give you an example. So we have absolute value of 2x minus 3 plus 2 equals 7. Okay, so to solve this equation, what you always have to do first, you need to isolate the absolute value. What that means, you keep absolute value only on the left side, you're moving everything else to the right side. So that positive 2 has to be moved to the right side. So we're going to subtract 2 from both sides. And that will give us, we'll just move that here, that absolute value of 2x minus 3 equals 7 minus 2, which is 5. Now when we isolate the absolute value, we're going to use the definition of absolute value. So to solve equation like this, second, solve two equations. So the first equation, it looks like your original equation. You're just going to remove the absolute value. So this is 2x minus 3 equal 5. And the second equation which you need to solve, you're going to remove the absolute value, which is 2x minus 3 equal, and you're going to change the number which you have on the right side to the opposite, which is -5. And now we're solving two equations, and that will bring two solutions. So we have 2x equal 8 plus 3, and we have 2x equal -2. Divide each by 2, and this is x equal 4, or here we divide everything by 2, x equal -1. So we have two solutions. So we solve absolute value equations, and again, remember, you're always going to solve two equations. So the solution set is 4, let's keep that in order, -1, comma 4. So that's the solution set of this equation. So again, a couple new steps. First, we isolate the absolute value. Second, we're solving two equations. So again, the first equation, it looks like your original equation, just without absolute value. The second equation, you change the sign of the number. which you have on the right side, to the opposite. Like you see, it's -5. And then you just follow the rules to solve the equations. So what I want to also show you, I want to show you how to solve the absolute value when you have double absolute value. So this is example 1. Let me give you the equation with double absolute value. So solve the equation with double absolute value. Not double. You know what? Let's just put with two absolute values. So this is how you're going to solve it. So let me give you the example. You have absolute value. You have absolute value of x squared minus 2x equal absolute value of x squared plus 6x. Okay, so we have two absolute values. How are you going to solve this type of the equation? So absolute value doesn't matter how it looks like all the time you're solving two equations. So you need, this is note for you, you need to solve two equations so the first equation, just remove the absolute value, absolute values. Okay, so just solve the equation like you see without absolute value. So we're going to have x squared minus 2x equal x squared plus 6x, and we're going to solve it. So let me just solve this equation. So since it's quadratic, we're moving everything to the left side. So I'm subtracting x squared from both sides, and I'm subtracting 6x from both sides just to have a 0 on the right side. So x squared will cancel. Here we end up with negative 8x. Cancel, cancel equals 0. Divide each by negative 8. And we end up with x equals 0. So that will be the first solution. Okay. Now, so the first equation, what we did, just remove the absolute value. Now, the second equation. So this is what you're going to do. Remove also absolute values. Copy the expression from the first absolute value without any changes, and in front of the expression from the absolute value on the right side, put -1. So this is what I'm talking about. I know it's a lot of writing, but again, I want to put that for you in case if you guys will forget, I want to go back later. So the second equation this is what you're going to do. You're going to copy the expression from first absolute value without any changes. So have x squared minus 2x. Okay, so I copy that. So we have x squared minus 2x equal. And here what I put it for you And in front of the expression from the absolute value, on the right side, put -1. So I'm placing -1 times, since you have expression, you're going to put in parentheses. And here you copy then expression which you have on the right side, which is x squared plus 6x. So the first equation, you're just solving like there's no absolute value. The second equation, the left side, the left absolute value, just remove the sign and you just keep that x squared minus 2x the same way, equal, and you're going to copy the expression from the second absolute value, but you're going to just multiply that by -1. And we're going to solve this equation. So we have x squared minus 2x equal, we'll distribute -1, that will give you -x squared minus 6x. And now we're just going to solve the equation for x. So let me add x squared to both sides. So we have 2x squared minus 2x equal -6x. And let me move that -6x to the left side, so I will add 6x to both sides. Okay, and that will give you 2x squared plus 4x equals 0. So now we're going to solve this quadratic equation. Since we're missing that the quadratic equation has a form ax squared plus bx plus c, since we're missing that real part, how you can solve it, this one, you guys definitely you can factor GCF, greatest common factor. So greatest common factor of 2 and 4 is 2. And the greatest common factor of x squared and x is x. So I'm going to factor GCF. Again, this is GCF. And again, inside of the parenthesis, so look what happened. 2x squared divided by 2x will give you just x. And here we just end up with 2. So again, when you factor GCF, if you have to distribute that GCF, you should end up with your original equation. Okay, so definitely this one, it's correct. And now when we factor GCF, look what happened. We have multiplication of two expressions. That means you're ready to use zero product property. Zero product property means that if the product is equal 0, that means the first expression is equal 0 or the second expression is equal 0. So we end up with x equals 0 or x equals -2. So x equals 0 or x equals -2. And from the first equation, we also got x equals 0. So now you have to put all the solutions together. So the solution set is -2 comma 0. Okay, so we have two solutions. So I show you two examples how to solve absolute value equations. One which has two absolute values, and just be aware that when you're solving equations with two absolute values, you always want to have absolute value of one equation on one side and absolute value on the other side. You don't want to keep them together on one side. Okay, so always separate those absolute value. Keep each absolute value, one absolute value on the left side, the other one on the other side. So next, what we're going to do, next we're going to solve inequalities. So next part is inequalities with less than or equal sign. Okay, so just I will put absolute values inequalities. absolute value inequalities with less than or less than equal sign. So that's what we're going to do. So to solve, absolute value of the expression is less than a. That means that u is less than a and u is greater than negative a. So look what happened when we're solving this type of absolute value. It's less than a. So the first inequality is just the same like your original. You're just removing the absolute value. The second inequality, you keep u. You're reversing inequality symbol and you switch the number which you have on the right side to the opposite. Okay, and don't forget that word and means intersection. Okay, so what that means, solve two inequalities, graph them together, and find the intersection of both of them, which is the common part. Okay, and you will do exactly the same thing if you have to solve the absolute value of u is less than or equal a. That means that u is less than equal a and u it's greater or equal negative a. So like you see the second inequality, just remember that less than match with the word and, which is the intersection. Okay, so and means stands for intersection. The same thing. So the first inequality is the same, like you see, just without absolute value. The second inequality, you're always going to reverse the symbol of the inequality and switch the number which you have on the right side to opposite. And you follow the same rules. So again, and means intersection. Okay, so this is what we're going to follow when you have less than absolute value inequalities with less than or less than equal sign. Okay, we can see that. Okay, so let's give me examples. So we have absolute value of 2x plus 4 is less than equal to 3. So I have less than, that means I'm going to find the intersection. So we're going to solve two inequalities. The first inequality will be just 2x plus 4 less than equal 3. And don't forget that less than match with the word and. The second inequality will be 2x plus 4, and we're reversing inequality symbol to greater or equal, and we're switching the number which you see on the right side to the opposite, which will be negative 3. And now we're just going to solve two inequalities. So here, rewrite as two inequalities. Okay, now we're going to solve it. So I subtract 4 from both sides. We have 2x less than equal negative 1. Divide each by 2. We're having x less than equal negative 1/2. Solve the second inequality. Subtract 4 we're getting 2x greater equal negative 7, divide each by 2, and we're getting that x is greater equal negative 7.5. And again, and. So when you solve both inequalities, we're going to find the intersection. Okay, so let's find the intersection. I'm going to graph both inequalities on one number line. The first one will be in orange. X is greater than negative 1/2. So I have negative 1/2. I'm sorry, less than equal. Less than equal, so I'm shading everything to the left side. And the second inequality, the solution of second inequality, it's in green. X is greater equal negative 7.5. So this is negative 7.5. Close the circle, greater or equal. So we're shading everything to the right. So and stands for intersection. So intersection is that's where two colors overlap. So this is our solution. Okay, intersection means overlap. So the solution set is interval bracket negative 7/2 comma negative 1/2 bracket. Okay, so that's the solution. Or you can put the answer that way. The solution set is, and this is using set builder notation, all the x's such that x it's between negative 7.5 and negative 1/2. That also can be the solution. So it depends how they want you to put the solution, using interval notation or set builder notation. Okay. So let's do more. One more. Let's practice more. So this one was example 1. Let's do example 2. So example 2, we have absolute value of 1 minus 4x less than 5. So again, less than means that you're going to have two inequalities combined with word and. So we're going to rewrite as two inequalities. The first inequality is just 1 minus 4x less than 5. Less than, again, means and. The second inequality, it's 1 minus 4x. We're going to switch inequality to greater than, and instead of 5, we're going to have negative 5. So now we're going to solve two inequalities. So I'm subtracting negative 1, and we have negative 4x less than 4, divide by negative 4, and we're getting that x is greater than negative 1. So again, don't forget that because we divide by negative number, I reverse the inequality. Solve the second inequality, subtract 1 from both sides, we have negative 4x greater than negative 6, divide each by negative 4, and that will give us x less than 6 over 4, which you can reduce it each by 2, and that will give you 3/2. So we end up with those two solutions. Again, less than stands for word and means intersection. Okay, so to see the intersection of those two inequalities, you want to graph them on number line. The first one, let's put it in red, x greater than negative 1. So open circle, and I'm shading everything to the right. The second one will be in orange, x is less than 3/2. This is 3/2 less than, so I'm shading everything to the left. And the intersection, it's the segment where two colors overlap, so this is the intersection. Okay, so we can write that the solution set So the solution is the interval from -1 to 3/2, both in parentheses. Okay. So next what we're going to do, so that was the solving absolute value inequality with less than or less than equal sign. So just remember, less than or less than equal means and, which is equal intersection. Just remember that. Okay, so next what we're going to do, I'm going to show you how to solve the absolute value equations with inequalities with the symbol greater or greater than equal. So here will be absolute value inequalities with symbol greater or equal. So to solve the absolute value inequality, which looks like this. Absolute value of u, it's greater than a. This is what that means. That means that u is greater than a or u is less than -a. So we're still going to solve two inequalities. The first inequality is original. The second inequality, we're switching inequality symbol. We're changing the number on the right side to the opposite. However, we don't have and anymore. We have word or. And or stands for union. Come on. That means union. So now what we're going to do, we're going to solve two inequalities, we're going to grab them together, and we're going to look for union. Okay, union. So union, the solution of union is we adding two solutions together. Okay, so you're going to see the difference. So just remember that the greater or equal means union. Of course, I'm talking here about absolute value inequality, not just regular inequality. So let's put it absolute value inequalities. Because regular inequalities, that's a different story. Greater or greater than equal means union, okay, which means adding solutions. Okay, and you will do the same thing if you want to solve the absolute value of u greater or equal a. So that means that u is greater or equal a or u is less than equal -a. So you're going to solve two inequalities. So again, steps to solve it. Rewrite as two inequalities. Solve each inequality graph the solution, graph solutions together, graph solutions on the same number line, and find union. Okay, and find union, which means part of the number line which is shaded. Okay, so let's do it. Let me show you the example. We have absolute value of 2x minus 5. It's greater than 3. Means, and we're going to rewrite as two inequalities. 2x minus 5, it's greater than 3. Or 2x minus 5, reverse inequality, switch 3 to negative 3. So we're going to solve two inequalities by adding 5 to both sides. We have 2x greater than 8, divide each by 2, and we're getting x greater than 4. Here add 5 to both sides. So this is 2x less than 2, divide each by 2, and you're getting x less than 1. And don't forget that we're looking for union. So when we graph both inequalities, when we solve both inequalities, we're going to graph them together on the number line. So the first one will be in red, x greater than 4. The second one, it's in green, x less than 1. And since I'm looking for union, so union is the part of the number line which you shaded. So we shaded here and we shaded here. So this is our union. This is our solution. So union, it's not the intersection. So the solution is the interval from negative infinity to 1 union, because we're adding the second interval, plus 4 to positive infinity. So this is the solution of this absolute value inequality. Okay, and I have a couple more problems which maybe want to practice a little more advanced. So that's it from this lecture, but I still want to practice maybe a little more advanced problems with you guys. So I will just practice a couple more. So the rest, what we're going to do, we're going to practice. Let's do one with solve. So we're practicing. I'm going to mix absolute value equations with absolute value inequalities. So the first one which I want to solve it is absolute value of x squared plus 3x equal absolute value of x squared minus 2x. So let's just review. You have absolute value equation with two absolute values. So always two solutions. Always two equations. So the first equation will be just remove the absolute value and copy everything else. And the second equation, so again, you will need to solve two equations. So the second equation will be x squared plus 3x. So here I'm not changing anything, equal -1 times the expression from the second absolute value. So that will change to opposite. So that's x squared minus 2x. So we're going to solve two equations. The first one, let's subtract x squared from both sides. So that cancel, we have 3x equal -2x. So let's move this one to the left side. I'm adding 2x to both sides. So we have 5x equals 0, divide each by 5, and we're getting that x is equal 0. Okay, so that's the first solution. And we're going to solve the second equation. First, I'm going to distribute -1 on the right side. So that will give us negative x squared plus 2x. And I copy the left side, x squared plus 3x. So since it's quadratic, we're moving everything to the left side. So I'm adding x squared to both sides. So that will give us 2x squared plus 3x equal 2x. And I will subtract 2x from both sides. So we have 2x squared plus x equals 0. To solve this quadratic equation, factor, greatest common factor. GCF stands for greatest common factor. Greatest common factor will be x. So you factor greatest common factor, and that will give you 2x plus 1 equals 0. And now you're going to solve two equations, x equals 0, and the second one will be 2x plus 1 equals 0, which is x equal -1/2. So also we got 0, since I already have 0, so I can ignore this, the second 0, and the second solution is -1/2. So the solution set is -1/2, comma 0. Okay, let me see. Okay, maybe this type of inequality. So I have 3 minus absolute value of x plus 1 less than 1/2. So here, what you guys need to do before you will create two inequalities, remember that first, you always need to isolate the absolute value. Isolate the absolute value, which means on the left side, keep only absolute value. So that 3 is going to be moved to the right side. So I'm going to subtract 3 from both sides, and we have negative absolute value of x plus 1 is less than -3, 1/2 minus 3, which means half minus 3. That will give you -2, 2.5, which is -5/2. Okay, now again, we still have to isolate the absolute value. That minus means that you have -1 in front of absolute value. So we're going to divide each by -1. So I'm dividing each by -1. Cancel, cancel. And now finally I have absolute value of x plus 1. It's less than, I'm sorry, we're dividing by negative. So inequality reverse. It's greater than 5/2, 5/2. And now, again, I have absolute value of x plus 1 greater than 5/2. So just remember that greater means r. So we're going to rewrite as two inequalities, symbol greater means union, and we're going to find union. Okay, so the first inequality is just going to be x plus 1 greater than 5/2, or the second inequality, it's x plus 1. We're going to reverse inequality symbol to less than, and we're going to switch 5/2 to -5/2. So we're going to solve two inequalities. So I will subtract 1 from both sides, and we have x is greater than 5/2 minus 1, which is 2.5 minus 1. This is 1.5, which is 3/2. Or here we're subtracting 1 from both sides, so we have x less than, so we have 2.5 minus 1, negative 2.5 minus 1, negative 3.5, which is negative 7.5. Okay, so R means union. When we solve two inequalities, we're going to graph them together on the same number line. The first one is in red, x greater than 3 halves. So I'm shading everything to the right. The second one will be in green, x is less than the negative 7 halves. So I'm shading everything to the left. And union, don't forget that union means that we're adding solutions together. So on the number line, everything what you shaded is the solution. So this is union. So the solution set is and we have two intervals from negative infinity to negative 7 halves plus, which is union, 3 halves to positive infinity. So this is the solution. Okay, and let me see if I pick something. I think the rest will be fine. I think that's enough. Okay, guys. So that's it. So this is the last lecture before the test. This is section 1.6. Okay, so you need to study this section. And I will see if you guys have any questions about solving inequalities or equations, let me know so I can always record extra video and either with reviewing homework problems or provide you more examples. But thank you so much for watching the video.